planet know why they really do what they are doing. Right? This is what Mr. Simon Sinek, a gentleman, has told in the form of a framework called Golden Circle. Right? So I always pick this framework for anything which I want to decide both in personal as well as professional life. Right? So whatever you want to do, generally you start with why. Right? So just to give an example, we all of us know popular brands like Apple. Right? So if you go and ask Steve Jobs or even Tim Cook, why are you really building Apple, or why do you even exist, right? So they will say, we always want to think different, right? So we want to question the status quo, right? So that's what they believe. They have built a brand called Apple, right? So how they do is, maybe they build a simple user experience, great overall user experience to get the mobile phone to be used by the masses in the planet, right? But if you ask what they are doing, they are just doing some computers or some devices, right? So that's how great people, great brands think. Always why is all about the purpose, right? So why do we really want to do something which is really meaningful to the society or the humanity, right? I know all of you are here to listen about AI and security. Suddenly you ended up landing in a TED talk, right? So I'm going to get into the topic in a minute. But what I'm trying to highlight here is, so today what all of us together as a community is going to learn, why do we really need AI for threat detection, right? So at the end of the day, I have seen diverse audience sitting here, some from the colleges pursuing cybersecurity, some are consultants, some are practicing SOC managers, analysts, some of the detection engineers. I heard everything across cybersecurity landscape, right? All of us fundamentally, why do we really want to get into cybersecurity? If you ask back of your mind, we all want to detect the threats, right? So it's all about threats everywhere. How do we really detect threats is what everybody is chasing towards. We can do some VAPT, we can do some compliance, we can do some application security, cloud security, data security, so on and so forth, right? The why are the fundamental purposes. We all want to detect the threats. Do you all agree? Alright, so now I am also going to get into the same framework. Why do we really need AI today, especially now, for threat detection? Are you all going to join me in this journey for the next 30-45 minutes? No, nothing into technicalities, no nuances, no detail, whatever jargons Michael was showing a few minutes ago, right? So let's understand the fundamentals and basics and try to understand why do we really need AI, whatever the buzz happening out there, for our threat detection, right? So I know all of us talking about a lot of vulnerabilities, CVEs, threats, rules, right? So incident, alerts, right? So cases, reports on our regular day-to-day activities from Monday to Friday, whether it is our work or to the customers, to the partners, to the people out there, right? So next 15 minutes, let's forget about cybersecurity, right? So try to understand what is happening outside cybersecurity to get into the real fundamental I was talking about. Let's play a small game now for the next 5 to 10 minutes. Simulation game. How many of you like simulation games? This is going to be mental simulation, not going to be physical simulation, right? So I'm going to give you some scenario, right, and ask you some basic questions, right? I want to hear what is that you would like to answer for the question A, and how do you really think. That's the simulation we are going to play for the next 10 minutes. Then we will get into all cyber threats, vulnerabilities, so on and so forth, right? So I'll take you to a place called Kurukshetra, where the great battle of Mahabharata was fought, right? So there is one side of the battlefield, it's an army called Kauravas, 100 great fighters. On top of that, heavyweights like Bhishma, who can never be defeated, and you have you have Karna, best archer in the world, and you have Drona, who is the teacher for the opponent army called Pandavas, right? So if you come back to this side, Pandavas only 5-member team, right? So they have to fight the Kauravas and protect their kingdom called Hastinapur, right? So now all of you put yourself on the shoes of Arjuna for a minute, right? I'm going to give you 3 options. End of the day, all of us going to protect Hastinapur. Option 1 is you will get 95 fighters, right, who are as good as the opponent Kaurava army. You pick that option and go to the battlefield and do whatever you want to do, right? So again, you want to protect Hastinapur. Option number 2, you get 5 heavyweights like Bhishma or Karna and so on and so forth. You take the help of these 5 heavyweights and again go to the battle and see how you can win over Kauravas. Option 3, you get an intelligent brain, called Krishna, right, who understands the tactics, techniques and procedures of Kauravas, how they really fight and how do you can proactively figure out how are they going to attack you and then protect your kingdom, right? So it's option number 3. After giving option number 3, it may sound easier, right? So now I'm going to ask the question, how many of you pick, maybe take 5 seconds to process on the head, don't be in a hurry to answer, right? Maybe I'll give you 5 seconds. Alright, how many of you pick option number 1? Can you raise your hands? Nobody? Good. Option number 2? Wonderful. May I know why?
It depends. Like in the context of Mahabharata, Arjuna was competent enough to fight. Krishna was just a mentor who can help him to overcome his obstacles. But I need to understand, like, if I can have only 5 enemies with me, I believe that I can manage with that based on my confidence. That's the reason I'm choosing.
Fantastic. Cool. We have one picking option 2. Option number 3? Oh, that's the majority. Can one of you tell why? Yeah.
Basically, Lord Krishna can guide himself.
Okay, sorry to interrupt. There is no Lord, there is no belief system here, only rational thinking. Why intelligent brain called Krishna you want to pick?
In battle, guidance is more important. So through guidance can be achieved.
Okay, do you all agree who raised hands? He says intelligence is important in the battle. Without intelligence, you cannot really defeat your enemy. I assume all of you who raised hands on the same page. Cool. Let's come back to the answer maybe after 10 minutes. I'm going to get you the next simulation game, right? So assume we all are keen. We all are sitting in this last mile office. Thanks for sponsoring the space to join and learn as a community, right? Assume suddenly the false roof here breaks and there are a lot of terrorists jumping here, right? And trying to attack all of us with a machine gun, right? So we all are going to get injured in a minute, right? So jumping down just like how we see in Hollywood movies. And one of you, right, so is assigned to protect the people of AISEC community sitting here, right? You get 2 options. Option number 1 is a machine gun, right? Option number 2 is a sniper gun, right? I want to know, you take 5 seconds and tell me which one you'll pick. Your job is to protect the people. I think 40-50 members sitting over here should be able to save their lives, right? Because terrorists are jumping down. So which one you will pick? I want to of course know why. Take 5 seconds and I'll ask you again. Okay. How many of you picking option number 1? Can you raise your hands? Cool. Maybe one of you say, why do you think option number 1? But I think all of us know machine gun is to fire in volume in a random fashion, right? So that's by design. Cool, I got your point. How many of you pick option number 2? Cool. Maybe one of you tell why. Just curious, maybe. Okay. Focus. Okay. I think what they are saying is, in this room, even if the terrorists come, maybe they will be lesser in head count, right? So, and we are large majority, assuming, so they are going to randomly fire at all of us. And the moment we are going to play the role of defending these people, we should be razor focused, right? We can't use a machine gun to fire everybody, but need to only pick the 3 or 4 guys who are jumping from the false roof is where you have to target and shoot. That's what they are saying. Always focus and pick the target fire. Otherwise, you will end up shooting the hostages, right? So they may lose life. Cool. The third one, today morning I'm coming from southern Bangalore to attend this event here in Madahalli. So in a signal, I realized there were people, I think you know all of us in India how religiously we follow road discipline, right? So when the signal was on a red state, there were a lot of bikers, they were just bypassing the signal and crossing, right? So there are a couple of policemen trying to stop, but they're really not able to do it. So this situation is where we want to see how we can solve better for those poor traffic police in Bangalore city, right? So we have two options, right? So one is we can install a CCTV camera and track whoever is breaking the rules on the road, and say autonomously you pick that person and scan the face and get the driving license and mobile number and just drop a message on some challan, right? So that's one option, number one. Option number two, you can also pick some drones. Assume drone is legal to fly in the city infrastructure, and it's a drone that can fly around and figure out what's going on, who is breaking the rule, and then drop the same challan on the mobile number through message or WhatsApp, right? So these are the two options. Take 5 seconds. I want to know which one you will pick. Assume you are the commissioner of police for managing traffic for the city of Bangalore. All right. How many of you picking option number one? Cool. Maybe why?
It's manageable, easy. It doesn't create traffic. It doesn't require anyone to just look after it or control it.
Anybody is not required to look after CCTV camera.
For the drone, anyone needs to control it and manage it.
Okay, maybe I should add that autonomous drone. Cool. Okay. How many of you picking option number two? Okay, some. Maybe that lady in the last. She can try. Why did you pick option number two? Oh, I think it can move around and figure out if the passengers or those commuters are really breaking the rule of the road, and then easily find. CCTV will have some limitations. Fantastic. Okay, cool. So now with that, I am going to get into our real business, right? So enough of simulation, hypothesis, thinking and all that. I'll get back to some of the answers we have heard, say in 10 minutes from now. I'm given 35 minutes for the session. So let's do some reality check, right? So everybody is talking about AI attacks happening everywhere, a lot of people getting compromised, all workloads are getting targeted. AI bust is happening, cybersecurity people should see how we can protect the organization, protect the country, protect the planet, protect the people, right? So all that is going on. Let's do some number crunching to understand this bust deeper, right? So what you see on the left hand side, I know some visibility issue. So it is telling the daily CVE count which is recorded in the last 5 to 7 years. All right. So you see a spike, right? So until 2022, so we used to get in NIST database. I think most of you know better than me. We used to get 30 to 40 CVEs. I'm sure all of you know, some of the students also, right? So common vulnerabilities and exploitables, right? So recorded in the order of 30 to 40 maximum till 2022 or 23. Suddenly this bus came AI, and you see the hockey stick there on the CVEs. So now it is still, the data is still October 2025. Daily, I'm talking about daily, just please bear with me. It's daily, not monthly or yearly. Every day we are finding close to 150 CVEs from NIST database, right? That essentially means every day, I think it is all discoverable metric, right? So there are a lot of schools we don't even know how many vulnerabilities, how many patches are being missed. So every day 150 tools and systems are discovered that they have some vulnerabilities in their platforms, services or whatever the piece of code they are writing, right? So coming back to the right hand side of this chart, that represents daily threat intelligence growth, right? So threat intelligence is all about the IOCs, right? So the compromised IPs, domains, URLs, file hashes, so on and so forth. And again you see hockey stick there. Again, exactly at the time when the GPT was launched and lot of model developments happening, LLM, buzz, right? So one more hockey stick on threat intelligence. So now, so 250% increase, right? So now we have two options, right? Assume for a minute all of us are attackers, right? So you know which systems and tools and services are vulnerable, which is your input feed, and you know which organizations are exposed, right? So that's your target feed. And a lot of vibe coding people are doing, right? POCs, vibe coding to automate their workflows. Imagine you are an attacker, not a seasoned attacker, right? You want to start a career out of building or deploying some attacks, right? You have golden data here, right? So you deploy a vibe code agent that get all the input feeds of all the CVEs and target the attack to the organizations, say JP Morgan and Chase, or some of the people from Allstate, Siemens, right? So people are trying to protect. So if they are compromised, it's super simple to craft a attack to get into these organizations, right? Fundamentally, thanks to AI, the attacker's landscape has become super simplified or hyper simplified, right? To be very precise. We all talk about efficiency across a lot of functions, verticals, workflows, so on and so forth with AI. That is all applicable for the attackers also, right? So this is something fundamentally all of us inside the community, outside the community are slipping from the top of the mind. That is exactly the reason for these two hockey sticks you are saying, and this is not going to stop here, right? So this everybody, when Sam Altman is saying this is just a beginning for attackers also, right? So this is going to become 5x in the next 1 or 2 years, trust me, right? So fundamentally the problem here is the attacks are getting deployed in minutes. So coming back to our threat detection, whatever or wherever we started the session all about, it's all taking weeks and months. So weeks is like super optimistic way of calling here, right? But I think some of you, I'm sure know, it takes months to even deploy some rules or some patterns to understand the anomalies, because a lot of moving pieces here, right? So even before AI, with AI, these moving pieces have become like drones, right? So they are flying around. We'll get into nuances in a minute. But yeah, so what are we going to do as a community to see this happening, right? So because fundamentally everybody, going back to our why, our purpose is to detect the threats, right? So the threats are skyrocketing, and we are still figuring out how we can learn AI and how we can grow in the career, so on and so forth. All of that can happen, but as a community thinking, we should all aim at how do we leverage AI to accelerate threat detection. So all of you agree? Shall we go forward? So now I'm going to spend a few minutes on 101. I know some of you already are familiar with detection engineering, but there are a lot of people who would have not exposed to what it is all about. So I'm going to spend next 5 to 10 minutes to give the fundamentals again. Let's understand what is detection engineering without AI maybe, and then get into how AI can really help, right? So today, I think the focus is only to understand why do we need AI, not on how do we deploy AI or what is that we have to do with accelerate threat detection with AI. So everything is all about why today. So a lot of philosophical thinking, so bear with me. So what is detection engineering? Right, so if you take any environment in the context of security landscape, every organization, right, so we'll have a lot of assets. Asset can be devices, asset can be the domain, asset can be the endpoint, can be a VM in a cloud, it can be an application, could be anything. So fundamentally, any application is a piece of software or sometimes hardware also that has association with some software. They all will be logging something. If somebody is trying to access, somebody is trying to do some work out of this, some system is running on some scheduling. So everybody is trying to produce lots and lots of logs, right? So that those logs is all nothing but the proximity trace log, we call it, right? So all of these are to be crunched, right? So I think as long as there is a CCTV camera here working as expected, no worries, right? If somebody compromises CCTV camera, even to understand if it is compromised or not, you should understand the pattern before and after, right? So to compare the pattern, you need to have access to the logs and take the logs to a common storage and then find whether the pattern is anomalous or not. So that's how I think getting into the basics, right, we have to do. That is why all the organizations, what they do is they take all these logs and put into a storage layer called SIEM. SIEM is the Security Incident and Event Management. I think most of you know better than me, where the fundamentally all these logs are put together in a centralized infrastructure. And of course, even to understand what is really anomalous, you need to index it, just like how the Google SQL query works or Google search engine used to work. You need to index the data and then you get into the metadata. Metadata is nothing but the field, right? So how many, say for example, somebody is trying to access a web application like lastmile.com, how many times a user is trying to access in a day, you have multiple fields or metadata here. The user is one, the time is one, the application domain is one, and the kind of the JSON format is one. So all of these are called metadata. Essentially breaking down the log into the unique indicators is what we call as metadata, right? So now we have a storage. We have started putting the logs into the storage, and there is an indexing happening which is breaking the metadata, right? So let's have a basic investigation or a hunting scenario where I think somebody told, right? So say lastmile.com is spoofed, right? So lastmile1.com is creating some phishing campaigns to all the customers of lastmile.com, right? So to do that, you know that lastmile1.com is kind of spoofed one. Even to understand if any impact has happened to your organization, assume you are a travel agency, you will pick the domain and you will just go and run a query, right? So fundamentally, the basics of any detection is writing a query. As long as you know how to write a query, you are a great detection engineer. You can put in your LinkedIn and tell your interviews that you know how to run detection rules, right? So you need to find the index for searching lastmile1.com and run the query on the data, and that will tell you that whatever the logs of this lastmile1.com has targeted your whatever data set and how many of them clicked on it, how many of them really have some level of interaction with the domain by giving credentials, so on and so forth. You will get to know once you break down the index with the metadata for this particular query and get the response out of it, right? So this is how typically you try to hunt if you are really really getting impacted with any malicious domain or any indicator of compromise in infrastructure. This is something anybody can do, right? So you know that there is a malicious domain out there. You are checking inside your organization whether you are really impacted or not. Super simple, at least to see in the PowerPoint slide. But the challenge comes when you have to do this on a repeated manner, right? So you need to continuously run this query to check if lastmile1.com is already into your infrastructure or not, right? So to do that, you need to schedule the query, right? So that is where there is something called rule that came into existence, that you cannot do this manually. Every 1 hour you cannot keep writing the query, execute query and see if the results are found or not. So people started automating this in the form of rule. Rule is nothing but the same query and you save it and you execute for some time frame, right? So that way that query gets executed, and whenever the query is hitting some particular scenario or a threshold, you get something called alert, right? So the rule is getting fired based on some heuristic, some whatever the pattern we are talking about, lastmile1.com, how many of the users in the organization has clicked on it is what the rule all about. And when somebody is clicking, and the rule, whatever the query will have at least some X number of results found, and that is what will trigger some alert to you in whatever the security incident event management tool, right? So this is again fundamentals of detection engineering. So step number 1 is to understand whether you impacted or not. You create a manual query. Step number 2 is what you automate that in the form of a rule. Step number 3 is where you see the rule is hit or rule is fired, and you see some alert is getting triggered. So are you all with me so far? Make sense? So now adding one more level of clarity, right? So on hypothetical situation, assume there are no threats, no attacks, no CVEs, no threat intelligence, so on and so forth, right? So everybody fundamentally, like I was telling, we want to protect our critical assets. You call crown jewels, you call critical assets, you call your intellectual property or customer data or personal data, it could be anything, right? So we all want to ensure we protect the critical assets in the organization, and you need to at least have the control in place so that you know that you have the confidence that you are protecting. So that's why this all started, right? So the idea of detection came to picture just to have the control in place that you are protecting critical assets. But technically, in the real world, coming out of the hypothetical world, lot of people trying to attack the organization, find the compromises and penetrate, so on and so forth. So that is the reason we want to find the anomalies. If anybody is really getting into our system or infrastructure, we started creating the rules, right? So the rules when they get fired, like earlier said, and we get to know what is the real anomaly here. Say some phishing email, you are checking, say somebody is trying to access application more than 10 times, and you get an alert, right? So 10 times somebody is trying to access, but every time there is the failure of the password, and you know that potentially the user is compromised, right? So then you need to go and reset the password, right? So that's what the containment all about. So once you do it, then you have to figure out how many such users inside the organization are having a similar pattern to really access a particular application, and you do some level of hunting to understand how many of the users really got impacted, A, B, how can we really remediate, C, and can we recover from this particular incident, right? So that's all we do. It's all a part of the same workflow, and that's where the detection and response come to picture, right? So first is to have the control in place. The second is where you build the detection as a capability, and the third is where you ensure you have detection and response working in tandem to ensure your critical assets are protected, A, B, the threats are detected, C, and they are responded. Clear so far? Alright, so now getting into a little more nuances, let's try to understand how we really measure this, right? So end of the day, once you deploy a query, so I want to keep it very simple, right? Let's talk about only query. So rule is still a jargon. So when you deploy a query, you need to ensure that query is working as expected, right? There are some metrics, right? So they call true positive. True positive is when your query is able to successfully find a malicious scenario, and then the alert is also fired. False positive, of course, all of us know, because day in day out in SOC teams we deal with false positives, and something is benign, but you get an alert, and after spending 30-40 minutes or 60 minutes, you figure this is a noise or a false positive, right? And false negative, of course, malicious, but there is no alert triggered for it. That means you have deployed a bad query to detect the anomaly. And true negative is that it's benign and there is no alert, which means still it's a good query, right? So you deployed a query and there is no threat in your infrastructure. So these are the metrics typically used to measure how accurate or how do you really deploy some good quality queries to ensure you detect the threats so that you can respond later. So now I am going a little deeper, bear with me, right? So to even arrive at true positives and true negatives, right, there are some metrics that is used, right? So if you go back to the ML world, I think a lot of data scientists, they will talk a lot of new jargons which we don't even understand, right? A lot of them keep posting papers, writing papers, posting on the social, but fundamentally only two metrics that exist to measure in data science, right? So one is still some visibility problem. So one is the precision, right? So other one is called recall, right? So how many of you heard about it, precision and recall? Fantastic. So I'm going to simplify it to the rest of the audience, right? So precision exactly means how many selected items are relevant, right? And recall means how many relevant items are selected. Looks like a tongue twister, so let's try to simplify it, right? So assume there is a bowl here, right? So blue color bowl, and we have mix of say red and blue balls, right? So on the basket. So we have, say, let's assume 10 balls we have. Out of the 8 are red balls, and say maybe out of maybe 15 balls we have, and 10 are red balls and 5 are blue balls, right? So all the balls are on a blue basket now. So there's a red empty basket. We want to pick and put the balls on the red basket, right? So the only condition is you have to pick in a bundle and put it there, right? So when you pick and put it there, assume you pick some 5 balls out of 15. So just to recollect, so totally there are 10 balls, and out of that 5 are blue, 10 are red. All right. So now you are picking in a bundle and you put it on the red basket. Assume 2 of that are red balls and 3 are blue balls, right? So we are putting all of that into a red basket, right? Now we need to evaluate the precision, right? So precision to put it into the red basket. So out of 5 balls, I think we picked 2, right? So 2 is what how many selected items are relevant. So I think this is a red basket, that means it should have only red color balls. So only 2 are relevant, totally you have picked 5 balls. So 2 by 5 is called precision. Are you guys so far with me? Fantastic, right? So now when I said there are totally how many red balls, do you guys remember? 10, right? So to ensure we pick all the red balls and put it in a red basket, how many are left? 8, right? So to ensure we put all the red balls into the red basket, we have only picked 2, but we are supposed to pick 2 plus 8, 10, right? So 2 by 10, which is what? 20% is what? Recall in this context. Clear? Clear? Right? So now let's come to our business. Same, maybe I think this is a green ball here. Right? So fundamentally when all the red balls are nothing but true negatives here, right? So and the blue balls are all about true positive. So whenever we say in the same analytics or whenever we do some level of investigation response, right, it's all about finding the blue ball and red ball, right? So blue ball is a benign scenario, benign alert, and red ball is all about the malicious alert, right? So how do we really pick the right red ball and put it on the red basket is all about the threat detection we have been talking for the last 15-20 minutes, right? So this is just a real world example. When you deploy a rule, I think the $1 billion question is where to keep the threshold, right? So you have to move around and figure out whether 5 times somebody failing login into application is malicious or 10 times, right? So it's very easy to ask, but it's not easy to write a query to play around, right? So that way you will have to play with the knob, and the knob will decide whether you are picking the red ball or not. So our objective is to pick all the red balls, or our objective is only to ensure whatever we pick more red balls. I'll repeat, our objective is to ensure we pick all the red balls, or just to pick whatever we have picked up, out of that many are red balls, right? So this is again fundamental question I am asking. So as again detection engineering mindset, all of us, which I believe we will have to carry after the session, is to ensure we pick all the red balls, right? So end of the day, our job is not to say we have created 10 rules and fired some 100 alerts and all of them false positive, we have responded, right? That's something. It's good to get a paycheck end of the month, right? But our purpose, going back to why, is to detect the threats, right? So the threats can be detected only when we pick all the red balls. Do you all agree so far? So then I think the simple math, the simple formula, you can just play around to ensure whenever you deploy a rule, what is your success criteria, whether it is precision or it is recall. So I'll again come to the AI landscape. I know I have 10 minutes left. Just to give another example is, so it's all about how do you balance between the recall and the precision. Before AI, I think it's pretty straightforward, because you know on a daily basis you get some 100 alerts, if you ask any SOC analyst, right? So 100 alerts or 1000 alerts still is manageable to look at. But if you see the kind of data and the logs we are creating after AI, right? So it is like 1000x, right? So when the amount of logs are getting increased, going back to the earlier slides, that means you have to index everything, and you will end up having a lot of metadata, and you need to ensure your query wins the real threat to discover or hunt, right? That becomes a real challenge. And manually writing the query or even scheduling the rule is good as long as you have 100 alerts and you have bandwidth to really look at what is really noise and what is really signal. But when it becomes like thousands or 100,000s or even a million, given the lot of adoption of AI across our organization, outside the communities, it is not practical, right? So human cannot just imagine, cannot deploy a rule and play around and fine tune the knob, whatever I was telling, to ensure that this is achieved. That's where the real challenge comes for human ability and capability, and we need to deploy AI. Some examples I think I already covered. Say when you want to deploy a rule for say SSH brute force, right? So what you do is you first understand the behavior and then try to figure out how many failed password, some of the metadata equivalent indicators here in the last 1 minute or 3 minutes or whatever time frame. You try to build a query for that. How if password is failed, and you go to the Linux logs and then count how many IPs within last 10 minutes with 10 hits or requests, right? Then you deploy the rule and you do some fine tuning, and then you end up saying that there is some alert started coming, but you realize all of them are blue balls, but fundamentally you want red balls, right? So just to increase your recall, you keep fine tuning the knob, and slowly you will start getting one red ball maybe after a week or two, and then another red ball after another 2 to 3 weeks, and finally third red ball will come. But totally there are 10 red balls, don't forget, right? So this process is what we do today in a manual workflow. So another correlated scenario, when somebody is clicking on a phishing email, and then you see the credentials are already compromised, and that compromised guy is trying to get into your other systems or infrastructure, we call lateral movement, right? Even in this case, you need to talk to 3 different logs, say it's a proxy log, your authentication log, and then try to pick the right metadata and the field and deploy a query, and same fine tuning, picking more red balls, how you can really do on a regular fashion at scale, and then deploy the rule and test it, and all it goes for some level of fine tuning. It is all like a development life cycle, SDLC, what we do in engineering, right? So in third direction, we call a direction as a code. I think some of you may already know. All that is good, but it's not scalable and it's not practical, right? Cool. Just another example how this query is written. I think I'll just skip this in the interest of time. I think the same logic what we discussed. End of the day, you need to pick the right logs, and you need to pick the right field, right metadata, and then talk to all of these logs and try to make sense of it and deploy the rule to ensure the rule gets maximum red balls for you. Again, coming back to the basics, attacks are deployed in minutes. If we are still believing that we can do things in our existing manual detection as a code workflow, whatever I have shown, creating some query and playing around and have multiple rounds of coffee in a day and see if this query really works, we are already lost in the game because the attackers are moving fast, right? So we have been told always data is the critical risk for everybody, right? So fundamentally that's how we have been conditioned, and most of us know about the cloud revolution, right? So in the cloud revolution, data started moving around. We all were told something called zero trust, right? Zero trust is a framework. So don't trust anybody who is trying to access data and how they are accessing, and something you don't control, right? So zero trust is still is relevant, is applicable, maybe till 2023, if you ask me. After 2023, it's all about speed, right? So you have seen attacks getting deployed in minutes. Unless we bring velocity back to the detection room, we are already fighting a lost battle. We are already accepting that there is no context for our scenario, right? So fundamentally, we are trying to bring visibility to our InfoSec leaders, right? So the leadership, which are the critical assets, how we can really protect protect the assets in minutes, but the reality is in months. And then how can we really detect the threats in minutes, but the reality is still weeks. And coming to the top metric called MTTR, mean time to respond, is still happening in days. I think everybody knows there is the breach report says 200 days is the MTTR number, right? So coming back to the fundamental again, we all should go back. I think at least after the session, I request all of you to brainstorm internally. Zero trust is good, but it's not sufficient in the age of AI. It's all about zero latency threat detection, right? So that's what we all, I think, start thinking around, because unless we bring the velocity to the table, we're not going to really protect our organization assets. In the interest of time, why it is, again, like earlier said, very difficult for our manual analysts or engineers to do, because there are 3 moving pieces here. If you see, look at any detection rule today to be deployed. Number 1 is the TTPs. I think MITRE TTPs is continuously evolving on daily basis. You cannot keep a track of it. And the assets are like shadow AI, shadow IT, all of us we know. So very difficult to track what assets you have inside the organization. Number 3 is where the threat intelligence, right? So there is threat intelligence, there's a spike. We have seen a hockey stick last 2 years, right? So how can you really connect the threat intelligence, understand which assets are getting impacted? How can you map your TTPs and then figure out you have high quality rules? That is also deployed on a very frequent fashion so that we are on real par with the attackers, right? So that's the challenge. This can never be done in a manual method. Of course, that's the problem, right? Coming back to the scenario, what we earlier discussed, number 1, most of you said you preferred the intelligent layer called Krishna. That's right. I think with AI, we can certainly bring intelligence to the table, right? So that's what is relatively easier when you compare with the non-AI world. And coming back to The second scenario where some of you said I would prefer a sniper to protect the hostages. That's all about recall, right? So recall is very critical to pick all the 10 red balls, right? So that's why we can still achieve a DI. And agility is important because one lady told about this, the flexibility of the drones that can go where there are anomalies, right? That is very important because we live in an era where data is completely siloed, right? So it's not sitting in one place. If you think that everything is in a seam, we are still in a old school world, right? So that way, what we need is velocity or speed with the power of AI, but still the missing piece in the puzzle is the context, right? So I think context only will come from all of us sitting in the room. So we know what is really critical. So what is the scenario that makes sense to our organization, or how our data is processed, or how our customers interact with data, the users interact with data. So that way the context is where we all should have to focus. Yeah, question. We all have to focus and then sort out how we can really adopt AI to ensure we accelerate our threat detection. And yeah, so in the interest of time, I'm going to skip some of the outcomes. Anyways, so as I earlier said, today the agenda is only to focus why do we really need AI and think as a team together and brainstorm as a community. And these are some of the capabilities what we have. I will just stop here with this some funny note. Everybody is talking about AI SOC, right? So, but bringing AI to the SOC is Security Operations Center, I'm sure most of you know, unless we deploy AI in the right place, the right time, this is how it looks, right? So you have a beautiful engine, but your fundamentals are broken, right? So you can put it on LinkedIn or you can apply in your job interviews, but when you on the hands-on, on the ground, this is how it looks, right? So I'll stop here. Yeah, so happy to take up questions. Yeah.
Question about the scenario. Biggest challenge right now is to correlate because all the sources what you have mentioned, their correlation point is different. You will have email, Windows you will have accounts, and if somebody is able to create a single communication, then you have a. So how you are going to prove that this is the machine that has happened on this particular machine is now creating a single communication. So all these three are different options. Correlation point is different. First. And second question I have on top of that. When you are going to correlate, your computation will go across. You need huge computation to correlate all this. Now you just scale a span of time. How you are handling that?
I think two great questions. I'll go one by one. To answer the first one, right? So like I was showing, like you rightly said, somebody is compromised on phishing, trying to move laterally and execute on your cloud, maybe a C2 scenario, and then try to exfiltrate some data from your application, right? So this is still a luxury query for me, right? So again, I'm going back to the fundamental. Still as a query, talking to three different data stores, right? So you are writing SQL query that has three indices, trying to fetch the data, right? And at the immediate first attempt, you may build a bad query, right? So whether you do by yourself or assume you deploy an AI agent to do on your behalf, you will end up creating a bad query. That's what I am again going back to the same fundamental. Whether it's a human or AI, doesn't matter. Query building is what it matters. First, whether it's again hybrid query, in this case a correlated scenario is all about hybrid query. So when you have a query that is firing noise at say T0, you need to keep changing your knobs, right? So changing your email logs, changing your the knob for your proxy in this case, and then getting into application logs also. So this knob changing is what takes time. To the human, if you ask, I remember some of them saying threat hunters here. I don't know who is that person. So they do this only, right? So either you hunt based on the IOC or based on the hypothesis, right? So what we just said is hypothesis based hunting. This hunting is the step one before even you do the incident management, right? So for this, at least the purpose of having some automation technology like AI is to do the fine tuning, right? So you no need to move around the knob and pick the more red balls here, whatever the correlation scenario here. So you deploy the agent